Okay, today we're going to look at Chapter 11 on radicals, and we're on section 11.2. We're going to add and subtract radicals. So when we add and subtract radicals, we need to have like terms. So the like term in this part is not going to be a variable, it's going to be the radical part. And so what that is called is like radicals, okay, when you have the same radical part. So with like radicals, if you have two of them that have the same radicand, whether it's 23 underneath the radical or 14 or whatever it is, and it's also the same root, so it's all either the square root or the nth root, then these are going to be like radicals. And if that's true, then we can say, well, a times the like radical square root of x plus or minus, whether we add or subtract, b times the square root of the same like radical square root of x is equal to now a plus or minus b times the square root of x. So we can either go ahead and add them and subtract them, or if they're variables themselves, we can leave them as variables, but we can take a plus the b or a minus the b and then times the radical x. Now here a and b are real numbers and x is some positive real number, and that's because we have x under the square root. Now this works for the nth root too. So a times the nth root of x plus or minus b times nth root of x is equal to a plus or minus b times nth root of x. Okay. Now remember, when we have odd values for n, we can have negative numbers for the x, and so that's going to be a key to remember. Now, when simplifying radicals with addition and subtraction, do that part first before reducing factors from the radicand. And then if there are no like radicals, then you have to reduce the radicand sometimes first to get like radicands. And so sometimes you might have to do work prior on the radicand part to get them to be looking like radicals before you can actually do any adding or subtracting of that a and b part. All right, so this is going to get us into the point where we're starting with ones that have like radicals in it, and then we're going to move to ones that don't have like radicals always, but we can get it to be by simplifying that radicand. All right, so what do we have here? Well, we have negative 3 squared root of 2 plus 3 squared root of 5 plus 3 squared root of 5. Well, the like radicals are radical 5 and radical 5. 2 is not. So what we're going to do is we're going to say, well, that just keeps out in front, negative 3 square root of 2. And then we have 3 plus 3, so that's going to be 6, and we keep that radical 5 here. So those are likes. We just add the numbers in front or subtract them depending on what it shows, and then we put our like radical afterwards. So we took 3 plus 3 and got our 6, and we still have our radical 5. What about the next one here? Well, again, we have 3 different radicals. 2 of them, though, are the same. We have the square root of 5 and the square root of 5. And so that means we can take and add those 2 together. Now, this one's different. So again, it's just going to be left out front there, 3 radical 6. We cannot change that into something with a radical 5 because that's just going to be 2 times 3. And neither one of those are perfect squares, so we can't take a square root of anything. And so we have 3 radical 6 plus, well, here we have 3 plus 2, that's 5, and then we keep our radical 5. All right, what about this one? Okay, with the 6, we have already said, well, we can't reduce that because that's, 2 times 3. So if we want, we can say that's 2 times 3. Neither one of those are perfect squares, can't do anything. 12, well, that's 4 times 3, and we can take a square root of 4 because that's a perfect square, and then that leaves us with a radical 3. So let's rewrite this now. So we have a minus 3 radical 6 minus, now the square root of 4 is 2, and we're left with a radical 3, and then we still have plus 3 radical 3. Okay, so here there were no like radicals, but now we have like radicals. And so now we can go across. Well, that 3 radical 6 stays 3 radical 6 there. And then we have here a minus 2 plus 3. So 3 minus 2 is 1. So we have plus, and 1 is, not necessary. We can just leave it as a blank there. And then radical 3. So if we wanted to, we could put 1 times that, or because we just know that that's only one of them there when there's no numbers out in front. Okay, so that's how we have to do it sometimes. We have to break down the radicands and figure out if there's something we can take an actual square root of or the nth root of, and then do that, and then we get our like radicals that we can add or subtract. All right. Now here, we could say, oh, automatically I've got, 2 like radicals, I'm done, I don't have to worry about this. But this one, square root of 18. Well, what is 18? Well, that's 9 times 2. The square root of 9 is 3. And so if we go ahead and, we rewrite that, square root of 9 is 3, so I have 3 times 3, so that's 9. Then I still have a radical 2, then minus radical 2, minus 3 radical 2. And now I've got 3 like radicals, not just those 2. So sometimes it's really important to try to see if you can break all of them down, because, even when we got the 6, we try to break it down. 3 can't break down at all. So try to break them down. If you can get them simplified into like radicals, you have more of them, that's even better. So now we have 9 minus 1 is 8, minus 3 is 5. And so then we have our 5 radical 2. Okay. All right, so this one, well, 18, we just did, 18, and that was the 9 times 2. And 8, well, that's 4 times 2. That will give us a square root. 20, well, that's 4 times 5. 20 here is also 4 times 5. Radicals, you can't break the 5 part, but you can take the square root of 4 and get 2, and you can take the square root of 9 and get 3. So if we take those square roots here, that's going to give us a 3 times a negative 2. That's a negative 6. And then we have square root of 2. Now here, square root of 4 here is going to give us 2 times a negative 3, so that's a minus 6 square root of 2. Now here we take the square root of 4, we get 2, so it's going to be minus 2 square root of 5. Now we take square root of 4 here and get 2 times 2 is 4, and again square root of 5. All right, so now we've got 2 sets of like radicals. We have the 2's and we have the 5's. So with the 2's, we have a minus 6, that's going to be a minus 12 square root of 2. And here we have a minus 2 plus 4, so that's going to be plus 2 square root of 5. And so then that would be our simplified version of this expression with 4 radicals. We've broken it down into 2 because 2 of them are like radicals here and 2 of them are like radicals here after we split them down. All right, so what about number 6 here? Well, 24, that is going to be, let's see, 24 is 8 times 3, I think, but then that's not going to help us any. So, so let's see, 4 and 6, I guess, about the only thing. So we do 4 and 6. That way we can take the square root of 4. This is going to be 9 times 3. That's 2 times 3, so that doesn't work, and that's 4 times 2. All right, so this one, what we have then is take the square root of everything here. So square root of 4 is 2 times 3 is 6, and we're still left with the square root of 6 under here. Now, if we take the square root of this, the square root of 9 is 3 times 3 is still going to be a negative, but it's going to be 9 square root of 3. This one we can't break down, so that's 2 square root of 6. Now, square root of 4 is 2 times 2 is 4, and we have square root of 2. So here we have a square root of 6. Here we have a square root of 6. Now the square root of 3 and square root of 2, those, they don't help us any. We can't simplify those. So not always will it help us. All right, so we have 6 plus 2, so that's 8 square root of 6. Then we have minus 9 square root of 3, and then plus 4 square root of 2. And now, because this is in lowest terms, we can't take square roots of anything under here. We know that's the most simple answer we can get to. At this point, when we had things, we could break it down. We weren't sure what it was going to come to, but this is broken down as far as possible, and all the like radicals have been added or subtracted, and this is the 3 terms that we get. So sometimes you get, go from 4 to 2, maybe even 4 to 1. Sometimes you go from 4 only to 3, 2 of them add together, and that's all. All right. 243. I believe we saw that before. That was going to be 3 times 3 times 3 times 3 times 3, 3 to the 5th. And so if we want to write that 3 to the 5th, we can do that. And so we have really here 3 and notice we aren't using square roots anymore. We're using fourth roots. So now we have to make sure we have to the power 4 to be able to reduce. So let's say that's 3 to the 4 times 3, because we can take and break this apart. We can say, okay, well, that's our 3 to the 4th, and it's still times 3. And so that one, when we take the fourth root of this becomes 3 times 3, which is 9, and we still have the fourth root of 3 here. So same thing works here. We're going to have fourth root of 3 to the 4th times 3. So the fourth root of 3 to the 4th is 3 times the negative 2, so it's going to be negative 6. And then we have our fourth root of 3. And then we have minus our fourth root of 3. There's nothing we can do here. So now we've got all of them have a like radical. And so now we just have to take 9 minus 6, which is 3, minus 1 more, which is 2. And so it's 2 fourth root of 3 as far as our final answer goes. Okay. All right, what about 324? All right, so that one, that's going to be, I believe, 4 times 4 times 4 times 4 times 4. So if we do that on a calculator, 4 to the 5th, that will give us, oops, that's not 4 to the 5th. It must be 2 to the 5th. Yeah, no. All right, so here we go. 4 to the, oops, wrong button. All right, so it's actually going to be, I think, instead of this, it's not going to be all 4s. We're going to have, you can divide it by 4 first time, but then it's going to be times 3 times 3 times 3 times 3, because you have 3 to the 4th times 4 is going to be equal to 324. So that's really what we have. So this is 3 to the 4th times 4. That's 3 to the 4th times 4, and that's just 4. Well, 3 to the 4th root of that, that's going to give us 3. So we have a negative 3, and then we have the fourth root of 4. Plus, well, then we have 3 times 3, which is 9, times the fourth root of, here we have 4, and then minus 3, and then the fourth root of 4. All right. So now what we have to do is just look at these, and we have all the same radicals. They're all like. So we have 9 minus 6, and so that's going to be 3 times the fourth root of 4. And so that would be our final answer. All right. So that one, a little hiccup there. I just was thinking it all was going to be 4 there, but it wasn't. It's actually the 3 to the 4th times the 4. All right. What about these? All right, so here the first one. Now we have fifth roots. So notice we have a fifth root, so we need to have something 5 times. All right, so 6, well, that's 2 times 3. So that one really doesn't help us anything. And so what about the next one? 64. Well, 64 is going to be 2 times 2 times 2, that's 2, 8, 16, 32, and then 64. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 2 to the 6th is 64. All right. So if we need the 5th, that's going to be 2 to the 5th times 2. Okay. And so we know that that one is also 2 to the 5th times 2. And so with 192, that one's divisible by 3. So if we take 192 divided by 3, that's 64. So that's actually 3 times 2 to the 5th times 2. All right, so now we're going to take the fifth root of those. Well, this one, guess what? It doesn't do anything. So that's still minus 3, then fifth root of 6 minus. Now the fifth root of 2 to the 5th is just going to give me a 2. So it's 2, and the fifth root of 2 plus. Now here, the 2 to the 5th, the fifth root of that is 2. So 2 times 2 is going to be 4. And I'll still have the fifth root of 3 times 2, which is 6. And now I'll have the fifth root of 2 to the 5th, which is 2 times that's going to give me a negative 4. And then I'll have a fifth root of 2. So I've got a 2 and a 2 and a 6 and a 6 for my like terms. So I have a minus 3 plus 4, so that's just going to give me a fifth root of 6. We have a minus 2 minus 4, so it's going to be minus 6, and then the fifth root of 2. Okay, so that one we had to kind of work our way down, break them down, and this was probably the more tricky one. So I saw that 9, 10, 11, 12, they added up to something that's divisible by 3, so I divided it by 3 first, and then I got my 64 left over, and I already had figured that one out. All right, so what about the next one here? Now we have the sixth root. So now we have to have 6 of them before we can actually take anything out, okay? So let's see what we have here. So 256, 256 divided by 4 is going to be 2 to the 5th. And so let's see here. That means that's going to be 2 to the 8th. And then this is going to be 2 squared, which doesn't really help us. And this is going to be, divide that by 5. So 320 divided by 5 is going to be 64, which is going to be 2 to the 6. And then 128, well, that's going to be 2. 64 times 2 is going to be that. So it's going to be 2 to the 7th. Okay. All right, 2 to the 8th. Well, that's going to be 2 to the 6th times 2 squared. This one is perfect. It'll break down easy. And this is 2 to the 6th times 2. So now we're going to take the 6th root of that. And here we'll have the 6th root of that. And here we'll have the 6th root of that. So the 6th root of this one is going to have a 2 come out. And so that'd be a minus 2. And we still have underneath there the 6th root of 4. Now here we have the 6th root of 4. Nothing changes there. So that's 2, and then the 6th root of 4. Now here the 6th root, 2 to the 6th, that's going to be 2. So 2 times negative 3 is negative 6. And we have the 6th root of 5. And here looks like the 6th root of that is going to give us a 2 times that's going to be a minus 4, and then a 6th root of 2. Okay, so what does that help us? Well, we have 2 like radicals, so we have a minus 2, so it's a minus 4, 6th root of 4. Now there's nothing similar here, so we just have minus 6, and then a 6th root of 5, minus 4, and the 6th root of 2, and that is as far as we can go. So that's what we need to do when we're working on these, is kind of break them down. We look, make sure we know what the root is, because if we assumed that was a 2 and not a 5, the whole problem would be wrong. So we have to remember, that's a 5, so we have to have 5 of those to make it pull out. And so then that's why I wrote these in terms of 5, and this one had to have 6 of them to pull out, so I wrote it in terms of the 6. And then you just simplify and get your like radicals, add like radicals together, and anything else that's there, it's not like you just have to put it on the end. All right, so that's all I have for this section.